let's go ahead and get started. If you would, please start by plotting your hurricane data. And please write a result sentence as the title to your figure. So we're doing pre and post in terms of when we think the effects of climate change may have influenced some measurement of hurricanes. We have two different measurements of hurricanes. We looked at the number of hurricanes. We also looked at the accumulated cyclone energy. From my perspective, you choose which of those you think is a better representation. That is fine. What I want you guys to put in the title is a sentence, a good result sentence with statistical evidence that illustrates that point. To do that, you want to open up your project. You may want to run through the code that you had all set up from before. In about a minute, I'll send you guys on to breakout rooms so you can work together on this. Now, one of the things in the breakout rooms that we did not see very much on Tuesday, when you get into a room, share your screen. If you got something that's working, share your screen. If you got something that's broken, share your screen, especially if it's broken. Then you as a group in the breakout room can go about trying to fix what that might be. This is good problem solving for everybody. If you have the broken code, you get a fix. If you don't have the broken code, you get practice trying to figure out where those problems are. Make sense? Questions? All right, Alexa, Hector, if you guys got video, go and turn it on. Maria, Emily, Erica, Michelle, same thing. Ariana, Lucas, Kevin, we would love to see you.
I'm on a desktop again. Should I switch over to my laptop?
Don't worry about it. If you're on a machine that's working for you, yeah, don't hesitate.
Okay.
And if you can't share, no worries. And if you really just don't want to share it, that is fine too. All right, let's get you guys in groups of 4 and 5. Emily, you stick around. Heather, you stick around. Not Emily. You get out of here, Emily. Heather, you stick around. Hey.
I was muted. Hi.
Hi. I'm not going to give him a lot of time. Maybe,
Okay.
5 minutes at the most, just to get the code going, and then they should be able to build it from there.
Okay.
Yep. Do you want to just pop out? And looks like you're on the bottom, so I'll just start on the top. You
All
start.
right.
All right. Have fun.
Hurricane data.
Hey, Billy, can you make me a co-host?
Yep.
I couldn't move around.
Oh, I'm so sorry.
It's okay.
And I'm about to send you out with Lacey and Elizabeth. Would anyone else like to jump out with Heather?
Could you repeat that? I know our group was still working and we jumped back
I'm going
in.
to send out Heather with Lacey and Elizabeth. Is there anyone else who would like to go out with Heather for like either getting the closing code, making sure you can import the CSV, and other issues that may have been coming up initially? Okay. So The rest of you guys.
Wait, I have a question because we were with Heather and we still couldn't figure it out. Do you think you can help?
Well, we're about to go through stuff.
Oh, I thought like that's what she was doing right now.
No, it's more like someone couldn't import to CSV initial state.
Okay.
Or, and one of the times, we'll get into it in a second. So you guys could see the RStudio, right? Okay. So blank file, Sam, what do I need to do to get myself started?
So you're gonna start by starting a new script first off.
I'm going to start a new script. Even though I've already been working, I'm going to recreate a new script.
Oh, I forgot. No, you're gonna go to recent files or recent projects and it'll probably be. right
Those are
there.
two separate things. Which one would be wiser to do?
Recent projects.
I want to go to recent projects. I want to find the project. So that's Hurricane 2 sample project. The whole point behind the project, it organizes everything together and you can transfer from one computer to another. Down here, all we could see is our script. But if I actually go back to the overall folder, you can see the project, the code, the data, and the output, which we're actually going to use in a second. Okay, so Sam, what do I do next?
Go ahead and open your project.
Open my project. Okay, we have the project right here. The same basic format is always there. We're going to first insert our packages, and then we're going to insert our file. So we load it. Do I have to install packages every single time, Kai? Or when do I have to install packages, Kai? Mr. Brown? Yep.
Yes, sorry.
Maybe keep yourself off mute and yeah, and then you can answer. So when do I have to install packages?
At the at the beginning, like if you're using the functions of the package. I don't understand your question.
When do I have to install packages?
Oh, if you're actually getting if you're using a new package, if you've never installed it before, and then
Okay.
after that you just have to load them.
Yeah, absolutely, absolutely. And you guys know virtual is much more difficult and it's very easy to be distracted. So do everything you can not to so that you're able to keep up on top of things. So we only install the packages exactly as Kai said, when we've never used it on that computer before. So each time on a new computer, you install packages. Otherwise, you just have to load them. We go down to our next line, we run that. That brings information into our field. We have a lot of NAs. We look at our summaries. Everything looks fine, but we have some areas where we have characters instead of factors. Ella G. Ella?
Yeah, what are you asking me?
Nothing. You had your hand raised.
Oh, that was from old. That was a long time ago.
Okay, well, you can lower it if you want.
How do I put it down?
You go to the participant. And
You go to reactions at the
Oh, I
bottom.
found
Thank
it.
you. Okay. One of the things that I want to show you that you can either do in Excel, but it's actually a lot easier to do it in R. And that is we already know how to select variables. That's line 22. We know how to mutate them so that we can make them into factors. That's line 23. Line 24 is one way in which we can deal with empty cells. So climate change has a lot of empty cells. In fact, we decided not to use any data that started before 1960. What this command does, drop _ NA, is it will eliminate any row of data from this variable climate change where that cell is an NA. And for us, that would be 1850, 1870, 1950, 1951, everything up through 1959. When you use this line right here as part of your overall data modification, it's going to create a new data frame that only includes rows where there's information in the variable climate change. So it's a really nice addition to do. It will do two things for you. It means you won't have to modify your original data set. The Excel file does not change. You keep it, you have all those ancestral, all those ancient data points, they stay there. But in terms of what we're working with R, we're only working with R in the data set that we want to analyze. So if you haven't done so already, I would add that in and I would give myself a note. So drop eliminates every row with an A in and identify variable. Now I'll give myself another note. Drop an A deletes rows where climate change is an A. 1950 and 1959. So it's a nice little device. It works well, helps organize your data, and it keeps things a little bit more simple for you than trying to change the CSV file and then re-import it.
I have a quick question about that function.
Yeah, Matt, go for it.
Is it, so drop NA only eliminates rows that specifically has NA written in those cells, or does it also eliminate cells that are blank?
It assumes that the cells are blank. So drop NA, the default is a blank cell.
Okay,
You can define it as NA, but drop NA assumes any blank cell is a non-applicable.
gotcha.
Great question. Others? Cool. So let's run that. We now have new variables. Notice one of the things here is our data set now starts in 1960. Because we've gotten rid of all of that previous data because those cells in climate change were blank. So they were treated as NA.
I got a question.
All right.
I don't know if you've mentioned in previous lectures, manipulating the CSV through R versus actually going into the CSV. So like on the homework, you ask us to choose like a date range and then manipulate that, but I don't know how to select specific cells, like specific rows and columns. So I went into the CSV and I pruned what I didn't want. Is that looked down upon? Is that frowned upon?
That is perfect for today. I will be teaching that command. If you would like a little, I don't know, let's call it jumpstart, you could use filter, where you can filter based on a variable being above, below, or equal to a particular number.
Okay.
So in this case, you could filter every year after a certain point. Again, I will show you that specifically later for the homework. All you need to do is exactly what Max says, and that is just change the CSV. Delete those things you don't need. Other questions? Okay. So we now run our summary just to check things. Our summary looks good. We have our pre and our post. We run our attach, and that all looks very good, but there is kind of a weirdness here. So let's first do our data analysis for number of hurricanes. That is looking good. So now, Alexa, what I want you first to do for me is just, give me a basic, good pattern. What seems to be going on? And I'm going to make a note.
Like the result sentence or?
Yeah. Give me a good result sentence.
There is a difference between pre and post 1995 accumulated cyclone energy.
Okay.
And I put the results of the test in parentheses on the end.
Talk to me.
T equals 3.57. DF equals, yeah, I'm not sure I copied them right, but maybe. 48.14.
Are you giving me accumulated? Oh, are you giving me number of hurricanes? I'm sorry. These
Oh, no,
data
this
are number
is
of
cyclone
hurricanes.
energy.
Difference between in, let me change that number of hurricanes because it's the same idea. And then we have 3.2. We have this weird thing, 44.2. And we have P equals, and we have, what is our P, which you can see right here, Alexa?
I said less than 0.01.
Yeah, but let's use the data as we have right here.
Okay, 0.00236.
And round it to 3 decimal points. Don't go further than that. Okay? Great. So part of science is rhetoric. We write out a first draft of a sentence, we then make it better. For that, ASBA, make it better. So Alexis gave us good information. There is a difference between pre and post. I'll collect some of my typos while we're doing that. I want you to make it better.
Could we make it better by like saying that there was an increase in number of hurricanes post 1995 compared
Is
to
an increase in the number of hurricanes after 1995. I'm fine with that. And you put that in the data. Clean, simple. Alexa, what is the difference between those two sentences?
The second one is more specific.
It describes the pattern. And do we have that information? Yep, we do. If we look at the number post, we look at the number pre, we do have that information. So don't hesitate to put it. So yep, this is a nice clean sentence. Is ASBA right in this case to make no mention of climate change? Is that a correct choice to make?
Yes,
Why? I think it's a perfectly correct choice. Why?
because saying it would be attributed to climate change would be, I mean, an interpretation, and we're not talking about interpretations right now.
Perfect. We are describing the pattern. The discussion of climate change is an interesting discussion. It may be a valid discussion. That's an interpretation of the data. Just describing the data is, and describing the pattern is the correct approach in this case. So perfect. There's an increase in number of hurricanes after 1995. You give the information. Make sense? Okay. So let's use that. Let's create our figure. And for that, Ariana, talk to me. Walk me through it.
Alrighty, so for the figure, I did a box plot. So it's box plot, parentheses, number of hurricanes. In my code, I have to have the little periods. I think yours has to have like the little side things.
Smart. And that's also a good observation. Remember, you have to do it relative to how you have the variables assigned in R. If you have little dots in between each word, you got to put little dots. If you have spaces between each word, then you have to use these back quotes. Keep going, Ariana.
The one like lone squiggly
Little tilde.
thing, I can't remember what it's called. Yeah. Climate change.
Okay. So now, Michelle, what do I do next?
I'm still trying to get the R script from a classmate, so I don't have it right now.
Michelle, do you want to break out with Heather to sort of get caught up?
Well, I just got sent it, so I mean, I have it now.
Okay. No, I'll call you on later. Not a problem in the least. LG, talk to me. What am I doing now?
Can you run it? Oh, after that, oh, are you adding colors?
Sure. Talk to me.
Okay. You can do COL equals rainbow. I forget what that is. Give me a second. I didn't add color. I think it's like rainbow.colors or something. Oh, you just do that? Okay, never mind. You can do that. Thanks.
George, what am I doing next, buddy? I actually don't think I see George yet. Paul,
I would do main and have your statement that you just put above there.
all right, excellent. Let's just copy it out. We know we like it.
Yep. Yep.
So we put it there, we highlight the entire thing, we put it in quotes. And Paul, this is going to run on really long. So what do I need to do to break this into two separate lines?
Just learn this. It's not the slash you think it is. It's the one above the enter key, and it's N.
So we did that. We have this little symbol right here. This \n, and that will do a soft break between the lines. And you sort of kind of fish around to see where you like it. In fact, you may want to do it in front of your statistical evidence, because that would actually be kind of aesthetic. You're going to line for the sentence and your statistical evidence is underneath. Paul, before I leave you, am I going to have to change my y-axis and my left axis?
Yes.
Okay. So I will let someone else answer that question, Paul. Appreciate it. For that, I want Victoria. What do I have to change?
So in the results sentence, we don't, in the title, we don't mention climate change, but the categories for the data that we have currently showing up automatically on the box refer to the climate change categories. So we should probably change those to the dates, and the commands for those are XLab and YLab.
Okay, so very good observation. And what would you want to call the XLab? If we're not going to call it climate change, as we talked about, that's interpretation. That's after the fact. We're first describing the data. So give me something to call it.
1960 to 1995.
That's pre-post, and we'll get that. But let's actually just say relative to 1995, and then we get pre-post. Relative to 95, pre goes beforehand, relative to 1995, post goes afterwards. Do we have to change the number of hurricanes, or is that okay? Is our YLab okay?
I think the YLab's okay.
YLab's okay. I get a little bit sort of weirdo when you have like capitalization in some cases and others. So I'm going to put number of hurricanes and capitalize it. It's a minor thing. I wouldn't even take a point off if you did that unless it was super weird. But we cool? You ready to run it? Paul? What you got, buddy?
Does main need to have quotes around it instead of?
Ooh, good question. It can have double quotes or single quotes so long as it's consistent.
Okay.
It
When I
cannot
ran
have
it like
double quotes.
when I ran it like that before, it didn't work. So we ended up putting quotes and it worked.
Well, let's find out. Maybe I'm wrong. We'll go. And it looks good.
Okay.
All right. So now, Maria, why does this make you go, huh? Or that's weird.
What?
You look at the figure, right? That I have on the screen, and right now I can see it in your eyes. You're like, that's weird. That doesn't make any sense. Now I'd like to ask you, why does this look weird?
Why does it look weird?
Looks really weird.
I can't. I don't. It doesn't look weird to me. Like, I mean, I see we have outsiders, but I don't.
We have some outliers. Now, do we kill outliers or do we accept them?
I think we just leave them there.
Yeah, we leave them there. We like outliers. We're going to keep them. Outliers are good data points. Erica?
I think it's the post being before pre. That's a little
kinda
weird,
weird.
like logically.
Yeah, you know, we write in English and we write left to right, and therefore smaller values are earlier values on the left, larger values, later values on the right. And we have this situation of post and pre are backwards. So, Hector, buddy, I need you. I need your help. Let's solve this. What can I do, buddy?
I'm not sure how to solve it.
That's
because when I
fair.
read it, I thought it made sense to me. I mean, I don't know. I guess your point is very valid, but not quite sure how to switch them around.
Give me a hint. Back here. It's all the way back when we manipulate the data. We've done it before. Does anyone remember? And this is an open one. This is not one I'm going to call in an individual.
I believe it was in the fourth section we did with descriptive statistics, and it either was like, I think it was the education one.
Ooh, clever. It is the education one. We had to reorganize everything, so it went from less education to more education.
Is that like, it's like MF row or like row count or something like that?
Generally, you get not MF row. MF row is what we use to define whether we want things organized in terms of multiple columns in a figure or multiple rows in terms of a figure. So it's another mutate. Mutate. And what we're going to do is we're going to go with climate change. And we're going to do equals, and it is fact underscore relevel. And then we want to do it of climate change. And then we want pre. And then we want post. And I'll leave it right there for a second. So we have an issue in our plot, but I'm going all the way back to when we're modifying the data to fix it there. Remember to give yourself a note. If you do it, go to try to run it. See if you can get things to work.
Hey, Professor, it didn't end up working for me.
Okay, and there might be a reason for that. So then go see if you can try to fix it. So one of the things I like to do in these cases is I like to clean up everything. Save all my stuff. Clear off my console and go back to the beginning. Reload my packages. This is the important step. When you re-modify the data, you have to re-import the original data. So I have to run line 18, run line 19, then I could do the adjustment. Notice my summary now is the right direction. It's pre first, then post. And the thing that I had to do is just a reminder, I had to do this step in order to re-mutate everything. So re-import the data, then mutate it. Do our attach, run our t-test, run our plots, and now everything looks good. I'll keep it up here, so in case there's so few people shutting this down, they can see that.
My function worked in the sense that I didn't get an error, but it didn't work when it came to actually reorganizing pre and post.
Great, let's see it. Show me.
Okay,
Or let me rephrase that, since you're about to show all of us, show us.
gotcha. So I did it here, and then where did it go?
Okay, so start by going to line 7. Oh, yeah, stop. Does anyone see it? This is awesome, Matt. Thank you very much.
He still has the education data.
Bingo. Yep. So
Oh,
Matt, in line 17, switch that education to back quote climate change.
yes, thank you.
Okay, now go starting from line. Yep, love it. Pre-post is looking right now.
There we go. Okay,
Lovely.
thank you.
So they happen. Little quirks, little things that sort of just set us off. Other questions, other observations? How many people, by the way, at this point are using ggplot2? I'm noticing a few individuals. Cool. We're going to start that probably in 2 weeks. We have a really nasty figure to make next week, and I don't want to force you guys to use ggplot2 to do that. I'll show you how to do that really ugly figure later at ggplot2, but we'll come to that in just a bit. Mateus?
I'm still not able to get it to switch.
Okay, show us your screen.
All right. Boom. Let me open that a little bit more, clean that up a little bit. Hi, everybody. This is what I got so far.
Okay, so scroll up, or actually clear off your console. So go down to the bottom, clean out everything. Of your script, go to your script, down to the bottom of the script.
Yep. Oh no, I have it out somewhere else. Hold up, I gotta get rid of you guys.
No, go ahead and try to run it from line 6. Run from line 6.
All right. Let me clean
Get
this
the variables
out.
back in.
Summaries, attach. Okay.
Yep.
Now run the pipe.
Let's yeah, go ahead.
Okay.
Do summary DF in line 17. You're fine. You're all good.
All right. So let's try this again.
Okay, so what do we have there? Scroll back up in
Yep.
your script. Your summary is fine, so run line 17 again.
Oops.
That is fine. So now just scroll down. How do I know that the summary is fine? Someone please tell me.
It says the pre before the post.
Pre is coming before post. Exactly. So, I got it. Go up.
Yep.
Go down to line 17, hit enter, and hit it and do nothing. Can someone please tell me why Mateus was showing the old arrangement and not the new arrangement? And the hint is in line 8. And look, Mateus is solving his own problem. He had it attached with the old post goes first, pre goes second, and he didn't reattach with the new pre goes first, post goes second. Therefore, we were saying the same issue. Yeah, so those lines right there, I would always do after you mutate. Do a summary,
Gotcha.
do an attach. Always after you mutate. That was awesome. Go to stop sharing your screen.
Beautiful. Thank you so much.
All right. So you make a figure. You like a figure. Want to save it. That's one of the very nice things about R. Now, this is a very usable figure. By our standards later in the semester, this will be ugly, but it's a good figure for now. To save it, go to export, and there's 2 basic ways to save it. If you want a static image, so like a JPEG, TIFF, PNG file, then go to save image. This is the aspect ratio you see in your computer. If you like the aspect ratio, keep it. If you want to change it to something else, change it. For posters, I tend to do 1000 by 750. So you could either do any way that you want. For posters, I tend to change my width to 1,000 by 750. If it's a wide figure, then I'll go to 1,400 by 750. If it's super wide, there's lots of columns, and I'll go to 1,800 by 750. Go to directory. And then you want to change directory to output, because we're going to put our graphs in the output. Open up that. Let me show that again. I go to directory. A new window opens up. I have my project right here. I have my code, I have my output, I have my data. I want to open up output. I want to put it in there. Notice my directory has changed. Hurricane underscore 2sample project output. And then you want to give it a name. And what would be a good name for this situation? And Max, you're up, buddy. Give me a good name for this file.
Results.
Okay, so that's a name that I very appreciate you said, because it was a good joke. If you put results, how many results are you going to have by the end of the semester? And they're all going to have the same bloody name. So in this one, I would put number of hurricanes, pre, post, 1995. So you have enough information that you remember or get at least a little jog of memory about what that figure is referring to. So again, I changed my aspect ratio from 1,000 and 750. I moved this to the output. I personally like PNG files. They're a compression, but they don't pixelate too hard, and they're very useful for online presentation. TIFFs cost a lot of memory. They're very large files. PNGs overly compress things and looks very pixelated and bad. You can do EPS, and I'll talk about that in a half a second, but I wouldn't. So we do this. We hit save. We go to our outputs, and we now have our figure, which you can now pull, use, and display anywhere you want. Make sense? If you want to modify a figure in a program like Illustrator, Paint, or another program that works with vector images, then I would encourage you to save as a PDF. Again, you define your parameters. You identify your output. That's where we're going to save it. And then you give it your name. And we save it. A PDF is a file that you can manipulate. So if you need to make some adjustments in the figure, and sometimes you do, this is what you use. You will never have to do manipulations of figures after R in this class, okay? Questions? Go take a 5-minute break. I'll see you guys back at 4:27.
Dr. Gunnels,
Mm-hmm.
I was still having an issue, and it was the one I think she said Ariana was having last week that she didn't have the code for.
Hey, why don't both you and Ariana, or just you, show me your screen and let's see if we can get it.
Yeah, I cannot for the life of me remember how you fixed Ariana's screen. So
All right, so let's start from.
I keep getting the.
Okay, so great. Let's go down to the bottom of your script, and I want you to clear off everything so I can see it. Brand new. Go to the bottom of your script.
And Kai, are you still there?
Go down.
Yes, I'm still here.
I'm gonna take Kai to a breakout.
Okay. And Elizabeth, can you go to the bottom of your script? And please run lines 65 through 7. Okay, now go back to the top. Great. And let's start running. Run. Run. Stop. Okay, go over to the environment just so I can see that. Okay, scroll down a bit. And the environment, go over to the right-hand side. Yep, perfect. Go scroll back up.
Usually if we have to do that.
Perfect, perfect. Go now run. Attach, summary, good, good. Okay, stop, scroll down to the council and let's take a look at the summary. Yep, I like all that. Okay, so. All right, okay, so stop. Okay, so I want you to show me lines 12 through 20. So scroll, move your, stop. Okay, there we go. There we go. Okay, so you have line 12 and line 14 are the same. So let's delete line 14. And now put a pipe. That's the percentage greater than percentage. Yep, perfect. And now, one of the things that's a good practice is to select the variables first and then mutate them. So let's move line 14 into line 13. So let's move those two, switch them. And let's cut it. Yep, paste, good. You're fine. Okay, now delete, yep, perfect. Delete back, okay, love it. Okay, so now let's look at line 13. What I want you to do is I want you to highlight from the parenthesis at the end of line 13, so before the pipe. So right after climate change, you have quote, then parenthesis. Start at that parenthesis, after the parenthesis, start there, and I want you to go all the way back to line 12. Yep.
So here
to line 12. Here? Yep. And now I want you to run that. Okay, now I want you to show me your environment. If you go over to data, down arrow, well, that's looking good. We got climate change, so we know that part. So now what I want you to do, run lines 12 through 18. So just put the mouse anywhere and run it. You don't have to highlight, just run. Yep, run. No, you're perfect. Okay. Oh, stop. No, you're going too much. Stop. Can we go back up? One at a time. Not a problem. So yeah, so all of a sudden we got errors. Okay, scroll down. Yeah, scroll up. Scroll up on the console. You're good. Keep going up. Up. Stop. Down a little bit. Right there. Okay, so pre-post is right. Accumulated energy is right. Number of hurricanes is right. Scroll down. Do me a favor, go down to the console where the little greater than symbol is underneath the error term, down, right there. And I want you to type in summary, parentheses, climate change. Then hit enter. Good. Oh, found it. It's so annoying, and I apologize. If a variable has a space, you have to use the back quote, which is a symbol below the tilde. So the same key as the tilde.
I don't have a space.
Look at it. Look at number of hurricanes.
Oh, wait. Okay, so right here.
Yep, delete that.
I have to do the quote.
Tilde key. Nope.
Sorry, what'd you say?
Delete the quote. Tilde key. It's the top left-hand corner of your keyboard.
Oh, okay.
Okay, now go back to the beginning. Yep. All right, now run it. All right, now, so get rid of the quote around climate change. Run it. There we go. There were two things that were happening. That function didn't call for the quote, but the more important thing was that back quote. It's obnoxious. One of the ways you could get around that is anytime there's a variable with a space in it, just rewrite the variable name and take out the spaces. Elizabeth, well done. That's it. You can share your screen or you can stop. Kai?
Yeah, so I'm gonna share my screen.
Yeah.
So I'm having trouble. Okay, so I'm just gonna restart my restart my script real quick. Just
thank you.
Okay, so loading my packages.
Yep.
Reading my data. Doing a summary. Just like as like a preliminary evaluation. Sorry.
Okay, so Kai.
What? Yes.
Oh, Elizabeth stepped off. I was just going to ask if you could show her how you actually avoid having to use the back quotes.
Oh yeah, that just the underscores, putting like changing them in the actual Excel file when you save it.
Yep.
I mean, I still use them just in case. I don't know. Makes my brain happy.
Okay.
Okay, so then I'm running this, right, which it all runs perfect.
Yep.
And then when I write summary again, though, I get this.
Yep.
We're like, so I don't know.
Go to line 19.
Yes.
Get rid of the back quotes on both sides of climate change. Try running it again. Okay, start with DF. So start with line 11 and then do the same thing.
Oh, line. Wait.
Just run line 11. Run
Oh, sorry. Yes.
again.
And then run this again.
Yep. Okay. So what are we getting? Open up your.
Okay. Yeah. Let me do, or here I can just like read DF, right? Or this. It's
But
this.
yeah, yep. So it's still keeping everything there. So go back to the hurricane. Go. Yep.
Oh, sorry. Every time I try to hit a different tab, like the drop down thing comes up, which is annoying.
All right. Get rid of all those back quotes, all of them. You don't need them because you don't have that space. Okay, so now run line 11.
Oh my god. Is there what's the shortcut for running a line? Like the control?
Just run. Oh, the keyboard key. I actually don't know.
Yeah.
It's
control
enter. It's super convenient.
What is it, Max? I didn't hear you guys.
Control enter. So when you type something, you can just do control enter. Like I can't not use it now. It's awesome.
Okay, so control enter. Max, give me like 10 minutes after class and we'll work this out. There's something I'm not seeing immediately.
Okay, cool. Thank you.
All right. So.
Can you put me in a breakout room with Heather?
Yep. And that's Michelle, right?
Emily.
Oh, my apologies.
Yeah, you're good.
Anyone else want to go out to the breakout room? All right. So. degrees of freedom. I told you earlier that the p-value is determined by the relationship between the test statistic, in this case, that's a t-stat, and the degree of freedom. The relationship between those two numbers defines the specific p-value. Now, what is, oh, I'm not showing my screen, so that's kind of obnoxious, but what is a degree of freedom? Because we report it, but what is it? For that, I would like to go with Matthias.
Yep. I'm actually learning this right now in my genetics class. So the degree of freedoms is basically the amount of variables you have in your, I guess, data set minus one, because the last data point that you have will always be true. That's the way they try to describe it to me. So you can kind of ignore it. So that way you, in our sense, say, for example, if we're comparing pre and post, we have two variables, so we'd only have one degree of freedom.
So I'm going to stop you there and say that was one of the best answers with some mistakes that I've ever heard off the bat. My assumption would be, what is the degree of freedom? I don't know. I just report it because that is a fair thing to do. So what I want you guys to do, grab a piece of paper. Grab a piece of paper, do it on your computer. I don't care. And Matthias, since you gave us such a very good answer, give me your favorite number.
42.
42. Good answer. Everyone understands the reference to 42. Is that correct? If you do not, then you have not lived a full life. Go read Hitchhiker's Guide to the Galaxy. Read it out loud to someone you love. It's a blast. 42.
Watch
Write
the
down
movie. It's
42.
great.
Okay, Matt, tell me your favorite number underneath 10.
6.
6. Okay. What I want you guys to do is I want you guys to put on the bottom of your paper, I want you to write 42. Along the side of your paper, I want you to put A, B, C, D, E, and F. Basically, the first 6 letters of our alphabet. We got that? So what we're going to do is we're going to sum up 6 numbers to equal 42. This is the concept behind degree of freedom. This is what Matthias was talking about. It's talking about the numbers which are free to vary given the actual distribution of data. Okay? So our sum total is going to be 42. We're going to add up 6 numbers to be 42. Make sense? Questions? Any confusion whatsoever so far?
Could you just say the definition again?
Degrees of freedom describe the number of data points which are free to vary given the distribution. And what we're doing is we're basically replicating that with this exercise. Our total is going to be 42. We're going to sum up 6 numbers to them. So, Matt, what's the first number? We're going to number up 6 of them. It's going to equal 42. What's the first one?
Let's do 13.
No.
No.
What is the first number?
10.
No, it is not. Carlita, what is the first number? So we know it's not 13, it's not 10. What is the first number in this sequence of 6 numbers which will add up to 42?
1.
No, but thank you. Elizabeth, Elizabeth? Yep, you're there. Elizabeth, what is the first number? All right, 6 numbers.
2.
No, it's not 2. It's not 2. Okay.
Could I try?
Who said could I try?
Me, would it be X minus B, C, D, and F? Minus B
No.
plus.
You're actually
No.
getting to the concept of degree of freedom, and we'll get to that in a half a second. So Hector is actually giving us why Matthias gave us a formula of n minus 1. We'll get to that in just a few seconds. So, Lacey, what is it?
Can you repeat the question?
Yep, 6 numbers, add up to 42. What's the first one? We know it's not 13, we know it's not 10, we know it's not 2, we know it's not 1. What is it?
4.
No.
I gotta, so it's 6 numbers, but you're not defining what numbers have to be, like, it could be any number, right? I could
Bingo.
do,
It's unknown. Thank you. The first number is unknown. It is free to vary. The first number can vary. It is a free number. So I'm going to make up a number. I'm going to say it's 41. So the first number is free to vary. It's a free number. It's one of our free variables. And I made up one. I am now just making it up arbitrarily. I said it was 41. Okay? So Kevin, you've now made a measurement, and the first number is 41. What's the second number? Do I see Kevin? Oh, I do, Kevin. Kevin, what's the
Yeah,
second?
I'm here. So if the first one's 41,
and it sums up to 42.
So that means that the second one has to be less than 1. So 0.5?
Nope. Olivia.
Is it free to vary?
It's free to vary. The first number and the second number, they are both free to vary. You have to measure them. You have to record them before you can get the actual total distribution. The first number is arbitrarily 41. The second number is arbitrarily negative 30. So the first one's 41, the next one is negative 30. I made those two up. They're free to vary. I've measured them. We now know them. Sound good? Lucas, do I see Lucas? Lucas, I see your printed name. What is the third number?
Is it also free to vary?
Free to vary. Lucas, what number do you want it to be? Because it's free to vary, you can decide.
21.
21, so now we have 41 plus negative 30 plus 21. Sam, what is the fourth number in this 6-number series?
I'm assuming it is free to vary.
It is free to vary, so give me a number.
7.
7, so now we have 41 plus negative 30 plus 21 plus 7. Kai, what's the 5th number?
Is it also free to vary?
It's also free to vary, so tell me what it is. Make it up.
It is 3.
3. So I'm hoping I'm keeping this correct, so guard me. The first number is 41. The second one is negative 30. The next number is 21. The next number is 7. The next number is 3. Add all of those up. Mateus, what is the 6th number?
I'm not very good at simple math. 1 second.
That's not a problem. Did anyone else get it?
you add them all up, it leads to 41. So the last number has to be 1.
Yeah, there it is.
The last number is not free to vary. That is what a degree of freedom is describing. In this case, it's describing the number of data points are free to vary given the sampled population, knowing the overall distribution. We know what the distribution is because everything is measured. Statistically, what we are doing is we're looking at how much of that is allowed to vary given the overall solution. The issue is the last number is not able to vary. So in this case, it would be n-1. Or the way Mateus talked about it, when you're doing something like a chi-square table where you do rows -1 times columns -1, same basic idea. It's describing the number of data points that are allowed to freely vary. It gives you an estimate of your sample size.
And then last number be 0.
Could the degree of freedom be 0? No. And if I coincidentally created a situation where it was 0, I would be freakishly embarrassed by setting you guys up for massive amounts of
we did.
confusion. So we got lucky, and I appreciate that.
So I added them up to 42, not 41, unless I am mistaken.
We're
I
gonna
think
say
it-
you're mistaken, Hector, just so it makes it easier for me. Not
that's
because you may not be mistaken, it just makes my life
Could
easier.
you, I mean, you could, couldn't you not? Like, so if you had 42, right? And you had A through F. And so right now, the way you have it is that you say, I want 6 numbers and they have to add up to 42, and you haven't put any constraints on what we can do. But if you add some arbitrary constraints and say, okay, A through F, I want to add up to 42 and all the numbers have to be the same. So all the numbers they can't vary, right? Because they all have to be the same and they all have to add up 6 ways to get to 42.
And that would not be an illustration of degree of freedom.
What would that be then?
That would be true mathematically, but it wouldn't help us understand what's going on with the degree of freedom.
Okay. But my point was that because I was thinking about it earlier. So if you start adding constraints, not like the one I said, but something else that made sense, then naturally you're going to tend down, you're going down in degrees of freedom.
Yes.
Okay.
And if we can come to this, degrees of freedom are typically whole numbers. Degrees of freedom for a t-test is your sample size minus 1. That has to be a whole number. In this case, though, our degree of freedom is not a whole number. In fact, it's kind of weird. It is 44.276, 44.3. The reason it is this t-test is assuming that the variances in your 2 samples are not equal. And just what Max said is what occurs. It takes some of that degree of freedom and it constrains in order to make up for the fact that you have unequal variances. And as a result, you get a penalty on your degree of freedom. To get around that, all we would have to do is go up here. And I'm actually not, let's go right here. Let's go help, t-test. And when we have variance equals, let's change this. Variance equal. If we make that true, this will give us a traditional degree of freedom, one based on a whole number. We'll get the same result. We'll get the same basic information, but now we'll get a degree of freedom which is more in line to what we would expect in terms of n-1. If you
Could
do
you-
not put in that var statement, then you'll get a degree of freedom that is penalized because your variances are not equal. And it will basically try to make accommodations mathematically because the variance structure of the 2 samples are not the same. Matt, question?
Yeah, I'm just still a little confused about kind of like what I understand how we would get a whole number, but why we need a whole number, if that makes sense.
You don't. This is something that most people with an elementary understanding of statistics get.
Okay.
This is something where some people with an elementary understanding of statistics would get very confused.
Okay.
If you care about talking about your science, you may want to describe your degree of freedom in whole numbers so you can talk about the science and not the stats. If you want to do something that is more appropriate for data, where the variances are unequal, then you present this, but some people are going to address you on the stats. And some people are going to get concerned about the stats. How is this possible? Why do you have a decimal in terms of your degrees of freedom? You can just answer. Next week, I'll give you another way of getting around both of those issues.
Gotcha.
Questions?
So why is our degree of freedom, like for a number of hurricanes by climate change, 44 or 44-ish?
Because, and Max actually said it perfectly. When the variances are not equal, and we have 2 groups, we have a pre-group and a post-group. When the variances in those 2 groups are nearly equal, what this procedure does is it accommodates for that issue. But in order to accommodate for that issue when calculating a t-stat, it penalizes the overall degrees of freedom. It basically puts a constraint on them. And this is the degree of that constraint.
That almost made, I don't know. I'm maybe more confused.
I'll give you a take home on this one. This is something I have to teach you. If this one slides over your head, never comes back in 2 weeks, you'll have a technique that will allow you to avoid this issue completely. But I have to teach you it because it is a key feature in introductory stats. So go with the flow for right now. And if this piece right here, unequal variances and this weird degree of freedom, are just sort of, we'll get around it next week. To test for variances, it's a pretty simple procedure. It's var.test, your x-axis by your y-axis. I'm sorry, your y-axis by your x-axis. You type that in there. If you get a low p-value, it means your variances are not equal. You should be setting it to false. If you get a large p-value, it means your variances are basically the same. You could set that variance not equal to true. Or again, you can just know that this occurs and we'll get some procedures around it next week. Hector?
Yeah.
Oh, I thought you had a question.
Oh, no.
Okay. Questions? Okay.
So wait, sorry, just going back. So a large p-value means the variance is equal.
Similar.
Similar.
Yep.
Cool. Just like, so like basically like the spread of the data for both data sets is, okay.
Yep. Great question. Other questions? Jackie.
I have a question about the homework, but if there's other questions about this specifically, then
Why don't you hold off until 5:10 on the homework?
Mhm.
And why don't we stop it early if there's anyone who has questions about the homework? All right. Normality is important. I'm not going to have you guys do this exercise. If you want to copy it so you can sort of play around with it later, but normality is important. If the data are not normally distributed by the group, so in this case, pre is normally distributed and post is normally distributed. If there is an exception to that, then you really shouldn't run a t-test. If we do any analysis and the data are not normal, we really should be doing something else. And a good example of that might be the spider canopy males parasite data. If you guys could please open a new script, please start to import that script into R. Please check to see whether either spider size and or web height is normally distributed relative to whether the nest had males or whether the web had parasites. Let's start checking for that. I'm going to put those notes into the chat. Then I'm going to recreate some breakout runs, and you guys can get started with that.
Okay, so I am trying to get into Canvas, but I have my phone with me, but I don't have the other phone that has the dual thing. Can anybody send me the file for me to
Yeah, of
download like
course.
through email?
Maria, give me your email and I'll send it to you right now.
Yes.
Okay, far away.
Okay, is
Oh,
that
there it
one?
is. You see it?
Mhm.
me copy that. Give me a few seconds. And okay, and I just sent that to you. There's no subject line.
I think I got it. Let me see. Yeah, I got it. All right, thank you.
Go ahead.
You're muted.
All right, so let's get a few things organized for next time around. I'm going to open up a new script, go to File, our script. I'm going to go back to my previous script. I'm going to grab some things that I need. Let's grab the load packages. Let's scroll down and grab the modifications. We'll probably use a lot of these, maybe not all of them. I want to clean up some notes just so it doesn't get so burdensome. At this point, I probably don't need to remember about mutate, keep those for the time being. And then as always, let's go get those end scripts. So we can have them at the end. And therefore, our stuff in the middle is what we're working with. Since we're starting something new, I'm going to run those end scripts and get everything cleared out from my environment. So there's nothing in there, and we are looking good. All right. So, Alexa, I now loaded the packages in again. We don't need any new packages today. What do I need to do with line 10?
Change it to the right file.
Okay. So I'll jump ahead and I'll delete that. Now what do I do?
Press tab. Well, did you download it?
I don't know yet. We'll find out.
Okay, so tab and data, and then tab again.
Okay, so no, I did not. If it automatically populates, there's only one thing there. So one thing we have to do is we have to put the Excel file in. There we go. Let's grab it. And let's just grab the CSV for ourselves. And then go put it inside our data. And now we should be good. So Alexa, talk me through it again.
Press tab again. And pick the spider canopy.
You got it. So this study student basically was doing canopy research, going up through the canopy, and the crew basically looking at how the location of the web and the spider influence whether they could attract mates or parasites. And in this system, these are golden orb weaving spiders. In the fall, right around this time of year, they're the big ones you see if you go into the woods, or sometimes even in people in eyes, you know, good, like face-sized spiders by their legs. The males are tiny by comparison. You know, if the female is like this big, the male might be about that big. And then along the side of these webs are something called dewdrop spiders. And these dewdrop spiders are also about the same size as the males. They're called dewdrops because they look like a drop of water. And what these guys do is they take food from any prey that the female captures. So what this student was interested in looking at was there a trade-off between the ability to attract a mate in terms of a male and the unfortunate ability of attracting parasites, which would take its overall forage. Does that make sense? If we run that and we look at our summary, we can see we have spider, that's an ID, we have dates, we have spider length, we have spider width, we have web height, we have males, we have parasites. All right? So, ASBA. What do we need to do here? Under select.
Do you have to select the male? You said in your notes that it's supposed to be the spider size or position, and then the males or parasites. So do you have to select the males, the parasites, and
If I
then
want to select the male and the parasites, do we want to select measurement of the spider size?
yeah,
Yeah, maybe spider width. What about web height?
yeah,
You
because
might
that
not
would be the
know.
location.
Now, do we really need date?
No,
And do we really need the spider ID?
no.
Maybe not. So how can we write code to get rid of variables instead of add variables? Someone remember?
Just do like minus select
Got it.
instead of select.
So instead of doing select and adding all the variables, why don't we just get rid of some? So we're gonna do minus spider and we're gonna do minus date. When we do those two, what do we get? We now have everything but spider and date. So that looks pretty good, right? Jackie? Do I need to mutate any of these variables?
Can you go, can I see your top right screen? Yeah. I wanted to look at those variables because I want to say males and parasites. Yeah, males and parasites.
Okay, so let's do that. So we'll do it right here. And Kai, do I need those back quotes?
No, because it's all one string.
So let's just do males. And let's do as factor males, comma after the quote. And then what else do I need to do, Jackie?
And then parasites in the same fashion. So parasites equals as dot factor, in parentheses parasites.
Okay, so let's check those. So notice what I'm doing is I'm highlighting the code before the pipe. And when I run that, it's just gonna run a part of it. Oh, I got a problem. What do I got? What do I got? Oh, because why did I get an error? Because I was dumb.
Because you already ran select.
I did. So I have to do df again, and then I can do it. Now that's working. We see over here, we're getting that. We can do summary, and we're getting yes, no, NAs. We got a lot of NAs, right? What do we want to do with that? For that, I would like Ariana. Ariana? Oh, I don't see Ariana right now. Ella G. And all I want to do is control for males and parasites. That's it.
Yeah. So that's where you would want to check if they have a normal distribution or no?
No, I want to get rid of my NAs. I don't want data with NAs.
Oh, can we use
Just
drop
males
NA
and
for that?
parasites. What's that?
Can we use drop NA for that?
We can use drop any for that. So what do?
Instead of like take out climate change and put in the two that you want. With a comma, I think.
And why have you, do I need to do this mutate? Do I need to relevel anything?
No.
Okay.
And do you need to put like the piping symbol after every time you use a command like this?
For this structure command, yes, you do. Each one of these is a line of code. The pipe tells you that they are all set together. So the pipe is basically a plus sign.
Okay.
So do df equals df plus do select, get rid of spider and date plus mutate plus drop NA. Questions?
So if you were selecting multiple things, you wouldn't need to pipe after it. You would just do select, pipe, and then whatever, or like mutate. Do you know what I mean?
You could, if I'm understanding you correctly. You could.
So like in line 17, you're switching from select to mutate, so you piped. So from 18 to 19, if I was to mutate like 20 more things, I wouldn't need to pipe again.
If you were to mutate as a factor, you wouldn't need pipe. You would just put a comma here, and then you would put the next variable that you want to mutate as a factor. If you were to mutate as levels or any other type of mutation we might do, then you do another pipe, mutate, and then do what that one is.
Okay.
And let me say, I'm not 100% positive because that's just the way I always do it. We could try to see if you could actually do mutate for different types of mutates.
It doesn't work.
What's that?
But it doesn't work.
Oh, thank you for checking.
But can you use the plus sign instead of a pipe?
Not in this area. We will
Not
with ggplot 2, but in terms of tidyverse uses pipes.
Got it.
Questions? All right, why don't we stop there? I will save the script. Questions on the homework?
Yes, I was wondering if we could do a class vote to move the due date from Saturday to possibly just Monday.
I have to grade over the weekend. I do not have any time during the week to grade. And if we
Then I
do that,
guess-
what that means is I will then have twice the amount of work the next weekend. So I made it on Friday. I moved it to Saturday to give you guys a little bit more time, but I cannot take on even more work the following weekend. And you know my schedule well enough to know I cannot do it during the week. So I'm sorry. Other questions about the homework?
Yeah, I have one. So in the instructions, you ask for a figure to be saved to the output folder, but you don't indicate what kind of figure you'd like. So I'm taking it that we're supposed to determine which figure is most appropriate.
And all of them are appropriate. The difference between them is PDF if you want to manipulate it after making it. Any of the other ones, PNG, JPEGs, totally fine.
Oh, no, I don't mean the file format. I mean like a scatter plot or a box plot or a bar graph or whatever.
It is appropriate for the data.
Okay.
In this case, that is going to be a box plot. I'll give you that much of a, information. Other questions about the homework? I will tell you one of the things you have to do with this assignment is you have to bring the two Excel files together. I give you two separate Excel files, you got to make them into one. But it's really the same thing we did with upper games.
But you said combine them into one Excel file or bring two?
One.
And also you note throughout the instructions that you want us to justify our decisions in notes next to like the test or the evaluation. But like at the end of the instructions, you say write a summary paragraph with all the information. So do you want it at the end or do you want it along the way?
I'd have to take a look at exactly what I said. I will say I tend to be very accommodating to what you give me. So as long as I can find it easily enough, you get credit for it.
Okay.
So we are doing a one sample t-test, right?
Doing a two
One sample
sample
test, sorry, one sample test.
two sample tests. You have to combine the two Excel files.
Oh, so it is a two sample test.
Yep.
Okay.
And I could give you, in fact, I'll load a single Excel file with the Shark data as one thing. But I'm going to put in there a variable that just has for 2000 through 2020 as post. You have to define the part that you're going to make pre. And I'll do that. I'll take that piece of confusion out of it. Other
No, I
questions?
was just confused because since the homework said one sample test, I didn't know you wanted us to do an actual two-tailed test.
Oh, I'm confused now because I'm not reading my own stuff. Doing one sample test, yes. Yes, thank you very much. I got myself excited about there, kids. It's a one sample test. Make a decision using the ancestral data. Come up with your expected mean using the old data, and you compare that to just the new data post 2000. Thank you, Kevin. It is a one sample test. Max, ask your question again.
My most recent question.
Yes, sir.
Okay, so within the instructions, you say that you want to have just justifications for the decisions we make about why we're using certain tests or evaluations along the way, like in notes. But what I was taking from it was that you also want a summary paragraph with like the same information, almost asking it to be done twice. So I just didn't know, you know, and not to repeat myself within the script.
And you're looking at the rubric for that.
Correct.
Is that correct?
Yes.
I'll just take out the word paragraph.
Okay.
Other questions? Okay. You guys are awesome. Have a good day. I will talk to you soon. If you have any questions, stick around.